If you have an AA agent set up like this with a Telegram trigger, and whenever it gets a message, it goes to the AA agent and generates a reply back to the user, it's gonna reply for each text that the customer is sending. And if this customer likes sending several messages in a few seconds, the replies are gonna look very automatic and spammy. You can see that for each message, 1, 2, 3, there are gonna be 3 replies. And that's not what we want. It doesn't look natural. So to make it more human, we're going to use what is called a debounce pattern. We're going to wait for 60 seconds to fetch all potential messages. And if after 60 seconds, no new message is received, we can assume that the customer has stopped messaging. Then we're going to aggregate all those messages into one single message, which we are going to send to our AA agent. The agent is going to generate a reply, and we're going to send that single reply to our customer, making the overall user experience feel more natural. So how do we do this? We're going to have our Telegram trigger as before and our agent and send message to customer as we had before. What we need to add is this blue section over here. This is going to work as a buffer. We're going to have a temporary database where we will store all the messages and then concatenate them all together before sending them to the agent. And to create a temporary database, we're going to use Redis. Redis is going to allow us to save all the messages from this user, fetch all these users' messages, concatenate all these messages into one, and then we're gonna delete the database. So let's get started. First, we're gonna need a set node because we need some information from Telegram. So we need to create an object that has the chat ID so that we know which person is talking to us. This is the unique identifier that Telegram has for that specific user. Next, we're gonna need the time when the message was sent because we need to know if it's been 60 seconds or not yet since the last message was sent. Next, we need the content, the message. And finally, we want the update ID. This is gonna be like the execution ID, because take into account that for each message that the user sends, these messages are gonna be fragmented. So if the user sends 4 messages, n8n is going to run 4 executions. And at some point, we need to stop those executions so that only one execution, the latest one, talks to the AA agent and replies to the user. We don't want the other 3 messages to talk to the AA agent and reply to the customer too. That's actually the reason why we get repeated messages. So that's why we need to identify which is the latest execution that's going to have all the latest messages. And Telegram lets us do that with the update ID, which is going to be up here. Now that we have our object ready with the 4 fields that we need for this to work, we're going to save this information into a Redis database. This database is going to act as a buffer. So for this, we're going to connect to our Redis account with our credentials. The operation is going to be push because we want to push this information. We want to save this information into the Redis database. And here we have list and data. Data is going to be the object that we just created with the set node. So we're going to send the message. This message is going to have the chat ID, timestamp, content, and update ID. And list is going to be an ID, a key to identify that specific customer. So that when we retrieve the messages, we only want to retrieve the messages for that specific customers and not the other ones. And Telegram identifies each user with the chat ID. So this is what we are going to use as the key of the list. We can execute the step and you can see that the information has been saved into our database. Next, what we need to do is once we save the information, we want to fetch the list with all the messages for this customer. And here again, to identify this specific customer, we're going to use the chat ID from Telegram as the key. We're going to execute the step and we can see that there's one message stored in Redis for this customer. And we are now ready for the most important section of the debounce pattern, which is this switch over here. The switch is going to receive all the messages from our Redis database, and it's going to have 3 paths. The first one is going to ignore the execution and it's going to do nothing. It means that the execution is going to stop here. We need this path to avoid repeated messages. As we said, for each message, there's going to be an execution running, but we only want one single execution to actually call the agent and then send a reply to the customer. Another path is going to be the continue path. This is the execution that has all the latest messages, and this is the one that's gonna concatenate all these messages and send them to the agent. And finally, we will have a wait path, so that when it hasn't been 60 seconds between each message, it's gonna give us 60 more seconds in case the customer is still typing something. So let's see how to set up the switch. The first rule is gonna be, if this is not the execution that has all the latest messages, meaning the latest execution, then we're gonna ignore this execution and do nothing. And how do we know if this is the latest execution? We're gonna compare our current update ID from Telegram from here. If this is not equal to the update ID of our latest message in our database here, then it's not the latest execution and it should stop. Our second execution is gonna control time. We're gonna compare the timestamp from our latest message in our database. And if it's been more than 60 seconds, in this case I use 10 just to make testing faster, but you can go back to 60 if you want. So if it's been more than 60 seconds or whatever seconds you want, you're gonna continue with the workflow and communicate with the AI agent and reply to the customer. And finally, if none of these two rules apply, we're gonna enter the fallback, meaning that there's been a new message within the last 60 seconds, so we need to enter the wait loop and wait for another 60 seconds. So next, we're gonna concatenate all the messages into one, and we need to delete the database. To delete it, we just need to specify which is the key, which is going to be the chat ID for that specific customer on Telegram. We can execute the step, and once executed, it's going to reply with the messages that it deleted from the database. So let's say we had 4 messages here. We will want to concatenate them all together and just send one big message to the AI agent. And to do that, we're going to use the set node. We're going to create a new field called full message, which is the one we're going to send to the AI agent. And what we want is to grab the list of messages here and just fetch the content part. For that, we're going to use this simple expression, which is going to do that. We'll execute the step. We'll have the full message here ready for our AI agent. So all we need to do now is connect it to our AI agent just by sending the full message as a prompt here. And now we have all the fragmented messages from this user concatenated into one single message ready for our AI agent to process, and the customer will now only have one reply to all the messages, making it look more natural.